What is the value of 36x minus 8y squared when x equals 3 and y equals -6? So we're just going to rewrite the equation. 36 times x is 3 minus 8, y is -6 times -6 squared. And so just take your calculator and work that through. So we've got 36 times 3, that is 108, minus -6 times -6 is +36, and +36 times 8 equals 288. So you end up with 108 minus 288. And you can do this on the calculator too, or you can do it in your head, either way, -180. And so we're looking at this, it would be this one right here, -180. Annie is planning a business meeting for her company. She has a budget of $1,325 for renting a meeting room at a local hotel and providing lunch. She expects 26 people to attend the meeting. The cost of renting the meeting room is $270. Which inequality shows how to find the amount X Annie can spend on lunch for each person? So I'll show you the answers. So, and there's 4. So this is A, B, C, D. The first thing you want to do, she's got a maximum of 1,325, which means it can't go over 1,325. So right away, you know that this is out and this one is out. It has, the inequality has to face this direction because the 1,325 is the highest she can go. Then we're looking for, she expects 26 people to attend the meeting. The meeting room itself is $270. And we're looking at, I'm going to get rid of this one because it's kind of in the way. So we're looking at $270, which would be this one. And we're also looking for how much money she can spend on the 26 people. So we don't know for sure how much she can spend yet, but it's going to be 26 times X or 26X. So the best answer, it would be B on this one. 26X plus 270 is less than or equal to 1,325. This is the number of people. This is the unknown price per person. This is the static 270 that she absolutely has to spend to rent the space. And this is her total budget. Dominic earns $285 per week plus an 8% commission rate on all his sales. So if he sells $4,213 worth of merchandise in 1 week, how much will his total earnings be for that week? So we've got to find, he makes an 8% commission. That means we have to find 8% of his total sales. So we're going to start with, I'm not even going to look at the answers because we should be able to figure it out. So he sells 4213. So 4213 times 8% is 0.08. So the total sales times 0.08, because that's how you turn the percent into a decimal, and then enter. So his commission for that sale is this, but we're not done. because he earns $285 per week. So 337.04 just happens to be this top answer, so I'm going to use it so I don't have to rewrite it. That is his commission plus his weekly salary of $285. So his total commission or his total pay for that week is $622.04. We look at the four. This is A, B, C, D. I had to write that in because the last one fell off the page. And the answer for this is D. And again, you get that by taking the total that he sold, 4213, times the 8%, which is 0.08. Multiply those two, you'll get the 337.04. Then you add what he makes in a week. And that equals 622.04. There are S steps from the pedestal to the head of the Statue of Liberty. The number of steps in the Washington Monument is 27 less than 6 times the number of steps in the Statue of Liberty. Which expression presents the number of steps in the Washington Monument in terms of S? And then here are the 4 answers they give us. However, I'm not even going to look at the answers. I'm just going to do the problem. So we've got S steps for the Statue of Liberty. And the number of steps in the Washington Monument is 27 less. So there's going to be a negative 27 or a minus 27. And then less than 6 times the number of steps in the Statue of Liberty. So we already know S is the number of steps in the Statue of Liberty. And this is 6 times that number. So we're going to say 6S minus 27. Now let's go through here and see if we've got one of these. Oh, right there. It's this one. 6S. Oh, no, it's not that one. It's this one at the bottom. Sorry. 6S minus 27. So there are S steps from the pedestal to the head of the Statue of Liberty. Great. The number of steps in the Washington Monument is 27 less. So that's going to be minus 27 no matter how we do the rest of the problem. We know it's going to be a minus 27, which immediately takes away this one and this one. So this one's out and this one's out. So now you've got 2, which if you didn't know how to do it by hand just from reading it, at least you've got it down now to where you can take their information and recalculate. So 27 less than 6 times the number of steps. S is the number of steps, so 6 times, that means 6 times S. This one doesn't work because we don't want it to be 6 times 27. We only want it to be 6 times S. So right there, 6S minus 27. A scientist is studying red maple tree growth in a state park. She measures the tree trunk diameters of a sample of trees in the same month every other year. The tables show data for 2 of the trees, and that's these 2 tables right here. This is the final year in which she will collect data. When her data collection is complete, she'll be able to predict future red maple tree growth. The scientist plots the data for tree 2 on a coordinate grid, this here. Which point is correct for year 3? So we're looking at tree 2, year 3. So here, tree 2, year 3, it was at 12 inches trunk diameter. So let's go down here, find the year, 1, 2, 3, and we're going to go up to 12. And that's actually B. I don't know if you can see that very well, but it's A here, B, C up above, D over here. And we're looking for the data point that equals year 3 and inches, 12 inches. So it's going to be B right there. It will be B. The scientist creates an equation that models her data for each tree so she can predict the diameter in the future. Select the linear equation that fits the data for tree 1, where X is the year and Y is the trunk in diameter. So we're looking at tree 1. That means we're going to be looking at this one. X is the year, Y is the diameter. And we need to find the equation that she can use to figure out year after year after year how much larger that tree trunk grows. So these are our answers. We've got Y equals 0.3x plus 18.3, 0.3x plus 18.6, 0.6x plus 18, and 0.6x plus 18.3. All right, so the first thing we're going to do, we need to realize that these are odd years. So we've got year 2, year 3, year 4, 5, 6, 7, etc. And we look at the difference between year 1 and year 3, because that's the data we have. 18.6, 19.2. The difference is 0.06, which means year 2 is 18.9. So every year, this tree is gaining 0.3 inches in diameter. So 19.2 in year 3, that'll be 19.5 in year 4, 19.8 in year 6. So see how it's going up? 0.3 every year. So that means we are looking at, if it's going up 0.3, that's the slope. That means we're looking for this number, 0.3 as the slope, because this equation is Y equals M times X plus B. B is the y-intercept, M is the slope, Y and X are the coordinates. So that means we can cross off these two because our slope is 0.3. We don't even have to look at those two. Now, are we looking at 18.3 or 18.6? So right now, we don't know what X is particularly. Well, we do, actually, it's right here. Year 1 is 18.6. Year 2 is 18.9. Year 3, 19.2. Year 4, 19.5, et cetera, et cetera, et cetera. So that means 0.3 is the increase every year. And we need it to add up to the first measurement. So it has to be 18.3 because 18.3 and 0.3 is 18.6. If we did 18.6, if we did this one, that's 18.9. That is too big. That's year 2. We need to know year 1. So this is the right answer. And I didn't explain that well. I'll have to re-explain that. But that one is your correct answer. This one is mildly complicated. And it's actually easy to do. You just have to remember a certain thing, and I will talk about that in a second. So the problem is, in year 13, the scientist will put tree wrap around tree 1 to protect it from the winter snow. The height of the tree wrap has to be 45 inches. The wrap is priced by the square foot. To the nearest square foot, how many square feet of wrap does she need? So look carefully at this picture. This is a cylinder. It's surface area for a cylinder. So we're going to look at our sheet, our formula sheet. We're looking for cylinder, 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 surface area. All right, now you see here Surface area equals 2 pi radius times height plus 2 pi radius squared. For this particular problem, you were going to cross off this part. You were only using the front end of this formula because this is for the base. And see, in this tree wrap, we have no base. So they're talking about when they give you this formula with the 2 pi radius times height plus 2 pi r squared, this is the base. If it were a bottle of water, let's see if I can do this. So this is a cylinder for all intents and purposes. And the second half of that formula is measuring the base. So the surface area of this bottle would include the base. However, the surface area of this particular problem, there's no base. They're just wrapping the tree. So we're going to go to cylinder, and we're just going to use 2 times pi times radius times height. And I'll write that down. 2 times pi times radius times height. Now, they give us enough information to figure this out. We know that, oh, and you have to, this is the other thing, on this particular one, you have to bounce back. You have to look at the table from the other part of the problem. I don't know why they didn't put it on this page, but they didn't. Because the first thing you need to know at year 13, what was the diameter of the tree? And at year 13, it was 22.2. And how do I know that I need to look at year 13? Right here. In year 13, the scientists will put tree wrap around tree number 1 to protect it from the winter snow. Tree number 1, diameter in year 13 was 22.2. So I'm going to write that here, 22.2 diameter. But what are we looking for in the formula? We're looking for the radius, which means the radius is half of the diameter. 11.1 is the radius. And then pi is always 3.14. So far we've got 2 times pi is 3.14 times radius is 11.1 times height. And the height of the tree wrap is 45 inches. So you see that? This is a formula. 2 times pi, 3.14, times radius, 11.1, times height, 45. Let's punch that into our calculator. So 2 times 3.14 times 11.1 times 45 equals 3136.86. Are we done? Well, let's look at the answers. We're not even remotely close to 3136.86 because these are our answers. 22, 44, 121, 261. But what do they ask us? Because this is inches. And we know this because it says in year 13, the diameter, inches, and the height, inches. So the number we figured out is in inches, but they want us to figure out how many feet. So we need to take this number and divide it by 12 inches because 12 inches is 1 foot. So we're not done. There's our 3136.86 divided by 12 equals 261.405. Right there. Look at that. 261. Because if you round this, the 4 drops off. The 1 does not increase because that 4 is 4, it's under 5, so it's just 261 when it's rounded. So 261 square feet of wrap is needed to cover this tree. This is complicated because when you're looking at the formula sheet that they give you during the test, I mean, this is the exact sheet you will have, and you're looking at cylinder, you know, it's pretty easy to figure out that's a cylinder, and you're looking at this, and you're going to want to do that whole thing. The problem is, this is the base. The second half is just talking about the base, and there's no base. So we only want to use the first half. Oops, that went blurry, didn't it? We only want to use the first half of that formula. 2 times pi times radius times height. And when we do that, they give us enough information. We can fill out the whole thing. We know it's 2, that's part of the formula, times pi, 3.14, times the radius. Well, they gave us a diameter, 22.2, so the radius is half of that, times 45, which is the height. And we get this is how many square inches. So we have to divide that by 12. And that gives us the feet, 261 feet. Perfect.